Okay, we're going to look today at how we do the algebraic version of direct proportion. Now, if we look here, the last time I did this lesson with Year 10 was on the 2nd of May 2 years ago, so it's roughly what we should be doing at this time of the year. What we're trying to do is take the sentence and turn it into algebra shorthand. So you'll see something along the lines of y is proportional to something or other, y is proportional to x in this case. They might say the word directly. If they don't have to. There might be another word there called inverse proportion. We'll look at that another time. So if we have y is proportional to x, what it means is y is some constant times by x. So this is like a multiplier, a scale factor, or something along those lines. And what they'll tend to do, they'll give us a pair of values for y and x to find what the constant is, and then ask us from that to then go on and find either y or x and give them one of the other values. So the first thing we're going to do is take the sentence, turn it into an equation that links y and x, and then use these triangles, you know I love these triangles, to help me find the value of the constant and then to help solve the question. So, given that y equals 12 and x equals 2, well, I just stick in y equals 12, x equals 2, and that tells me how to work out k. Because it's k times x is why I've written it this way around. Well, that k times x, or k and x are next to each other. In this case, how do you find k? 12 divided by 2, k equals 6, so y equals 6x in this case here. And obviously nice and straightforward, when x is 5, y equals 6 times 5, which is 30. Or you don't necessarily have to do this, but you could do y equals 6 times 5 there like that. This is more useful when the question becomes a little bit more complicated, because the statement might be y is proportional to, and it doesn't necessarily have to just be x. It could be, in words, x squared. My equation then will be y equals k times x squared. Let's have a look at doing exactly the same setup there, but with x squared rather than x. I will change my triangle, y equals k times x squared. Remember, it's now a bid mass setup, so I'm squaring the x, then multiplying by something or other. That's where I find it. Still the same values, but it's going to change our answer. So y is 12 and x is 2. Let's try and find k in this case here. It's 12 and then x squared. So k equals 12 over 4, which is 3. My equation then, y equals 3x squared. And then stick in 5 for x, and don't forget I'm squaring the 5, not the 3 times 5. So y is 3 and then 5 squared, which is 25, so y equals 3 times 25, which is 75. Okay, so different answer because of the fact I've got the different wording there. So all we're doing, we take the sentence, turn it into algebra shorthand, set up our triangles like this, because it's a product, k times something or other, like that. Find the k. If it wants the formula, rewrite it, and then use it to find whatever it wants afterwards. So, second example, it says h is proportional to the square of r. We're given that when h equals 2.5, when r is 5, it wants the equation that links the two, and then find h when r is 4, and find r when h is 90. This is going to take a bit more work at the end here. So, our setup, let's rewrite it as h equals k times r squared, or h on the top, k r squared. So k then is going to be whatever h is, 2.5 over 25, which is over 10. So my equation is h equals 1/10 of r squared, or r squared over 10. Either form like that. R equals 4 when h equals whatever's. Let's try and find it. H, k is 1/10, and then 4 squared in there, which is 16. H equals 16 over 10, 1.6, nice and straightforward. H is 90, ooh, now then. Got all sorts going on here. I've got 90 on the top, k is a tenth, and I'm finding r squared now. When I cover up r squared, is 90 divided by a tenth, which is 900, and don't forget I found r squared, not r, so r equals root of 900, which is 30. It could be plus or minus, by the way, because I'm square rooting. Always check the question in that case there to make sure that r has to be positive. If it's a physical thing, it will be a positive answer, not negative. And last example, there's my sentence, y is proportional to the cube of x, y equals k times x cubed. Exactly the same setup, given two numbers, find k and hence the equation, and then in this case, given y is that, find x equals. So there's only one step at the end. So triangle, y, k there, x cubed there. Stick in our values, k equals whatever y is, 1000 over, 8 cubed. I might need a calculator for this, to be honest. It's going to be a bit beyond me. Let's have a look. It's going to be 10 over 8, 5 over 4 is 125 over 64. I'm hoping that the figure's giving me a nice value for x at the end here. So I'm going to use that as my k value. Let's do a nice big triangle here because I've got a big fraction. Y is 1728, k is my 125 over 64, and I've got x cubed. So x cubed is y, 1728 divided by 125 over 64. I knew I'd need this eventually. Fraction 1728 on the top, on the bottom is a fraction as well. 125 over 64, oh gosh, that's a bit of a mess. And then 110592, 110592, all over 125, but that's x cubed. So I need to do the shift cube root of my answer equals apparently 48 over 5, SD over 1, 2, 9.6. And there's no plus or minus because it's a cube root, so it has to be positive, like that. So that's quite a complicated one. That's going to come way into the second half of a higher paper because of the nature of it and how you want to do it. But using these triangles, I think, is a good way to go.